All right. Hmm. Ah, that makes me so happy. All right, let's see if it's showing my screen. Perfect. All right, looks like we are in business, as they say. All right, so I guess let's get started. It's been a while since I've live coded, but I figured, hey, why not get back into it? Things are starting to calm down, summer's coming on, and it's time to get back into producing content. So here we go. Welcome, everyone. All right, so we got a couple people, and that's good enough to get me going. So what we're going to do today is I'm going to be building a bigger app, and I just wanted to make sure that my rig and all that was still working. And it turns out on my Linux box it wasn't. There was an update to OBS that's breaking my X instance, and it makes everything just go haywire right now. So I had to move to the Mac temporarily. But so now I just want to make sure everything is working and all that. So today's just going to be riffing and playing with a couple monads here, using this Crocks lib. Uh, it's a library I've been working on. I'm just going to play with a couple of these. So we're going to play with this async here, and we're going to play with this reader. And then I'll just show you how to use a reader with an async. That's pretty cool. We'll just talk about like what these things are, play with them, and play with all these functions, see what they do, things like that, with a silly contrived example. So, hey, welcome. Oh, how do you say that? Do you pronounce the D? Is it Zedko? Are you still here? Oh no, you're still there. Zedko. Anyway, welcome. So, without any further ado, let's just get started. So, we'll just get this going and let's move it over 30. I don't know if 30 is going to be enough, and let's get it to work with there. It's kind of, we'll adjust this little feller here just to get it to there. Beautiful. All right, so let's get started. We'll jump into Vim here and jump into our index. So we're not going to need Ramda here, but one of the things we are going to need to do is get Crocks in. So we'll do add Crocks, and this should Croc. And in English, I tend to say the D as well. I pronounce it when saying it in my language. Oh, what language do you speak? What's your native tongue? If you don't mind me asking. All right, so here, sorry, old habits, huh? All right, so now we see that we got everything up and running. And first thing we want to do, I guess, is to bring in async. So we'll bring in the async. Now, this type is a lot like task you've seen with like Folktale maybe, or Fluture. They do one of these. There's a couple of them out there that are really good. I just have one that works with the stuff I like to do with them, you know. So that's why Crocs kind of has its own. And so what this basically is, if you're familiar with promises or anything like that, it's just a way to capture an asynchronous flow and allow you to write them declaratively. One of the main differences between these and, say, a promise. Oh, Czech Republic, awesome. Oh, I've heard of that country. I've totally heard of the Czechs. um, so let's see here. The async basically just works like a promise, so to speak. So just so we can see kind of what it does, things like that. We will just make a quick one here. So we'll make a const m is equal to async. And the async actually takes a function, right? So the function that it takes is something that will be ran. And just like a promise, it takes a rejection and a resolution. So whenever you're done with it, you can either reject or resolve the async. The difference here is well, one of the differences is it's flipped. Notice the reject comes first, and that's because we kind of follow this saying, to the right is correct. So the furthest right thing is the correct path. And as you'll see, like with a lot of these, they're called sum types. What happens is the furthest right, actually, let me show you how this is defined. So in async, I should have done this. In async is actually parameterized as an error, or as we call it, a rejected and resolved. So this is the type for it. Now it's a sum type or a union type. So what that means is it can be either or. It can't be in both states at any time. It's either a rejected or a resolved. And whenever something's resolved, once we do our maps and our chains and like all these algebras that we do over them, the furthest right is going to continue along. So if I map something on it and it's in a resolved state, or the farthest right thing, it's going to continue mapping on that. If there were 3 of these, if I were to do just a normal map or things like that, say there was another state to this, then the furthest right would always be the one that map and chain and all that work on, and the other 2 would not be. So anyway, that's just why it's to the right. It's just a common, how would you say, standard, I guess. I don't know, convention. That's the word I'm looking for. So just like a promise, like when you're setting these up, you want to go ahead and build out some sort of asynchronous code. So just for this, we'll do a set timeout. Real simple. And then from here, we'll create a function that will console.log, or we don't even need to console.log because we're in my playground here. So we'll log out and say inside of M, right? So we'll do that, and let's do, this should be fine. Okay, inside of M, and then we'll wait 1 second. Whoa, goodness gracious, that was going to be a lot more than 1 second. And we will resolve, after reporting that, we'll resolve to some value. So we'll just put 23. So we'll just call this little thing M. Now the difference between a promise and an async, remember I was saying some are eager, where these aren't eager, these are lazy, is right now if I were to have made a new promise and did that, it would have started running the second I did new promise. But right now, if I save this, like nothing's going to happen. Like nothing at all. And that's because it's not eager. It needs to actually be told when to run. So what we can do is use a function on here called fork. And fork is the thing that says, hey, go ahead and fork the process, get it going. We want this to do its business, right? So then we can do fork, and fork takes 2 functions. It takes the first function is what to do if this async is rejected, and the second function is what to do when this async is resolved. So what we can do is we'll do log.bind, and we'll just bind this to null, and we will say rejected. Okay, so if this is rejected, we get that. If it's resolved, then we'll have this resolved little helper here. And delete this and do one of these DDs. So now when I fork it, notice we get the call inside of M a second later. And actually, let me show you this. We'll say inside of M defined, and then inside of M executed. Executed. called spelling Ian. Have you heard of it? That's probably totally spelled wrong. So notice we get defined, and that runs, the code inside of there runs once it's defined, but then a second later, and we could even delay this even more just so you could see, right? So we'll do result 2. Inside of M, it waits 2 seconds, and then inside of M executed. So this thing only executes whenever you go to fork it. So that's one of the main differences between a promise and an async like this, or something that works like this. So if that makes sense, I hope it does. And if you notice, my label over there is res. If we were to have rejected this, right, then we would have rejected, we would have called the rejected log. So notice over here that the log is rejected. So that way we're able to respond to any bits that are depending on the state that's there. So if we need to like send it to error break, or we need to do a certain thing anytime there's an error in this async progress, we can put a composition or a function inside of there that takes care of whenever this errors. So like what's the big deal with these, right? Like who cares about these? One of the neat things that you can do with them is say I get this result back and everything's good. I can respond to it. I can like take whatever value. So for instance here we have this rejected. So say I want to double that, right? So whenever this runs, I can create a function that's going to take some x and then do x times 2. And then as long as it's resolved, you'll notice that it takes whatever that is and it multiplies it by 2. So that's pretty awesome, right? It just works out that way. Let's get rid of some of this clutter here now that we kind of know what's going on in there. So we can take these and like say we're doing a database call and we want to just pluck certain attributes on it for a specific flow. Then, I mean, the other neat thing is we can share this. So actually, before we do that, let's go ahead, because we're going to be doing a lot of forking here. Let's go ahead and create a helper function to do the forking. And let's do this by, we'll add a helpers.js and we'll bring that in. So now we have this helpers. Let's make a function called fork. So we'll take a fork, and what fork does is it's going to take some sort of M, and then it's going to, and actually let's just do it this way. Because it is going to be an M, we can go ahead and just do fork on this, and we will call fork. No, actually we can't do that. I mean, we can, but it's fine. We'll just do it this way. No need to get clever and cute. Alright, so what we'll do is take an M, which in this case is going to be the async, and then we'll call fork on that, and here we'll bring in log. We'll just get some of your stuff when we make these little helpers. They can get a little unruly and things like that. So what we can do now is pretty much just take the same thing that we had here on 14 and put that here. And now we have a fork function that we can use. Let's go ahead and export this. Alright, so now we have a fork function. We'll bring this in and we'll do const fork and do require helpers. So many fat fingers, it's ridiculous. Okay, give this a save, bring this over here, give this a save. Of course, we're going to get an error here. Alright, so now we have this fork function, so we can get rid of this and just make sure everything still works. We'll do M, or we'll just call fork and do M. And 2 seconds later, it still works. Okay, so all we did is just made a little helper. Now we can just call fork. We don't have to worry about that. And for this, we can just put that away for now. We just have that little fork function. All right, so while we can map and do things like that, that's really cool. But what if we want to do specific things? One of the things you'll notice is if we map, so if this ends up getting rejected, notice it doesn't do the multiplication. Hi, how are you doing? Welcome. Notice it doesn't do the multiplication of multiplying this by 2. It only does that on the resolved or rejected or things like that, right? So that's because map, like I was saying earlier, is only going to work on the farthest right parameter of an async. So an async, again, is defined as a rejected and a resolved. Right, so this left side is the rejected and the right is the resolved. Doing pretty good. It's good to get back into the live coding thing. Hopefully I'll be able to pick up some steam and do all the fun stuff again. Should be a blast. Oh, you know what I just noticed? My camera is the wrong camera. Sorry about that. Let me... Goodness gracious. See, this is why. This is why people should pay attention to the things that they're doing. Boop. All right, there we go. That's the right camera. So silly. Are you using React because I see JSX? Where do you see JSX at? I'm not using React. This is just a node, but where are you seeing the JSX? Oh, javascript.jsx downstairs. You're talking about this right here? Yeah, totally. So that is just... I set up my types to work with JSX as well. So I will report a JavaScript file as a JSX file, and then that way all my little helpers and everything that's working. It's something to do with Vim. It's just the way to do the files. That way I can be in a JS file, but it will still do the file type as a JSX and a JS. So it just maps the JS. It's for the syntax highlighting and stuff. It's just easier to keep it on all the time. Anyway, yeah. So we have the little async bit here. Oh, and we're using ESLint here. If you're ever using, if there's any Vim users out there, if you upgrade to Vim 8, you can use the automatic linters now. Or if you're using NeoVim, it actually has the hooks built in. Whereas before on 7, you weren't able to have it run like on every key change and things like that. So now I got in Vim the ESLint working. See, res is defined and never used. So now I feel like one of those real fancy IDEs. Pretty good times. All right, so enough about all that boring stuff. Back onto the exciting stuff. So we got this async here, and all it's really doing is either rejecting or resolving, right? Not a big deal. Let's cut this to 1 second. So let's look at some of these other things you can do with this, right? So we had that map. We just saw what map does. Of is pretty cool. Of is just going to create something. Like say we wanted another one, right? So we'll make a const n is equal to async dot of, and what this is going to do will always resolve an actual async to whatever value we put in here, right? So if I do 23 like we did there, let's actually make it 33, right? Why not? So I can take this n, and if I fork this n, it just does all the hookup for me, right? Except it happens instantaneously. So this way I don't need to go, and every time I want to do an async, I can just do, it's kind of like doing a promise.resolved, and just to create a resolved promise. We don't have one for rejected, but you can use this on the constructor. I do. Oh, I do. That's right. I did add those. So if I wanted to make a rejected promise or something like that, I could actually use rejected here, right? And now I can get a rejected promise of 33. See, so notice it's rejected. It's following the rejected flow, not the resolved flow. Makes sense? And if I do resolved, it'll give me, ooh, resolved. Oh, did I take that out? You silly little goose. Oh no, it's called spelling Ian. Again, I'm not the best speller in the world, if you saw my last tweet before I went out. So notice now it gets resolved, but that's basically just shorthand for of, because anytime you call of on one of these algebra or one of these data types, what it's going to do is it's going to give you back the furthest right. Do you have a programming teacher experience? No, I don't. I'm not very good at this. I do. I have been doing some egghead lessons, so I do egghead stuff. If you guys want to check me out on egghead, some of my lessons are free. I think all of them are free. I'm not as good as like your Dr. Booleans or your Andre Stoltz. I can never say his name right, but I do all right, I guess. I don't know. I like it. It's something to do anyway. So now, if we check this out, we're back into our normal M. So that's basically what of does. Of will just let you create an async, a resolved async, basically, right? So then we also have this coalesce. This is kind of another one that's kind of different. This one comes with Crocks. You won't find this algebra pretty much anywhere else. But what coalesce does is it will move a rejected to a resolved, right? Now I need to check the code here real quick because I don't remember if I got something in or not. So let me just jump here and then we'll jump into async. And this is where all the code is. Like if you're curious, this is the code for this async that we're working on. But I want to go to coalesce, and it does take two functions. So what's going to happen with coalesce is it takes two functions, right? So right now, if we notice, we're rejected and we're not doing anything right there. We're just rejecting to 23. It didn't multiply it by 2 like it would have had we have gotten our resolved in there, right? So there comes a time where through your flow, you don't really care if it's an error, but you just want to get back on track with some sort of default value or something like that. That's where coalesce comes in. So we can do a coalesce, and this is from, did I spell that right? This is from, you've seen this operator if you've ever done any SQL or anything like that. It coalesces like a null value into something else. So that's why I kind of picked a name for it. But remember, this takes two functions. So say if it's resolved, we want to bring in a constant of something. And we want to just use identity on the other one. So if it's resolved, we want it to continue on, right? And just so we can kind of see a little bit more what's going on here, we'll do that map and then do the double, right? So with coalesce, like I was saying, it takes two functions. So we can use this constant function, and what this does is I can give it a value, so we'll just call it 0. We want to do this times 2, not plus 2 for double. I can give it a constant value, and what's going to happen is it'll give me back a function that every time I call that function that it gives back, it's going to always return whatever I passed it. So constant will give back a function that will always return 0. You've seen this in Ramda, like as always or things like that, but that's basically all it is. Identity is just the same thing. It's real simple. Identity. What that's going to do is if I give it a 3, it's going to give me back a 3. Or in this case, if I do this resolve, it's going to give me back a 23. And that's all it is. So what's going to happen is when I call coalesce on here, or when I call this async, I'm going to take that async, I'm going to call coalesce on it. Coalesce is going to give me back another async with these functions applied to it. And then I'm going to call map on the async that coalesce returned. And then I'm going to map whatever the value is there. So remember, like I was saying, we'll just comment this out right here. If this resolves, notice we'll get, 46. 23 times 2 is 46. So we'll get that back. If this is rejected, however, we're going to get back the 23 because it's going to reject with 23. Right? So it's never going to call this doubling function. So what coalesce does is it lets you resolve it. So what it's going to do is, since this is 23, it's going to take on the rejected function, return a 0, which will then become resolved. So coalesce will move it from a rejected to a resolved. And you'll notice over here how we have this rejected equals 23. What we're going to see now is a resolved 0, because 0 times 2 is of course 0, if it all works out. Yep. So it does. It all works out. We get our resolved of 0. But notice it's resolved. And we could have made this anything. Like we could have made this 10. So now this would be 20. But now check this out. If we were to resolve, because we did this right here, this is going to give us back whatever it is. So since it's resolved, it's going to keep it resolved, and then it's going to map it to there. So we'll get back our normal 46. We could also do something here, like maybe, that's just pointless. I think you guys get the flow of what's going on there. Now, kind of like this, or a little different than this, is swap. So what swap does is if I have an actual, let's see here, where's swap? So if I have something that's rejected and I want it resolved, I can resolve it. Or I can, I'm sorry. So if it's rejected, it'll get moved to resolved after running the value of the rejected through a function. And if it's resolved, it'll go to a rejected, running it through that other function. So I can take this out, and just so you see how it behaves, and replace that with swap. And notice I get rejected with 23. And that's because it didn't do this map, because at this point it got rejected and skipped over this map and then completed with that. Now if I want to swap, or if I make this actually rejected first, I'm going to get a resolved of 20, because it now went, and this when it went here, it became resolved, and then resolved got passed on to map, which got multiplied by 2. So same sort of thing. Now we could also, if you want to see what the 23 looks like, we could put identity here, and all it does is swap those values one for one, so we'll get 46 again. And if this becomes resolved, we just get 23, because it never runs that map. So now that's good for, the reason why it does this with the reject and resolved is it lets you capture disjunction, like it lets you capture the if. So if I don't have a good value or something that's like kick and bum and things like that, I don't want to run the rest of my flow. I just want to skip over all that stuff. And like for instance this map and bits like that. All right. We don't really, alt is different. You don't use that a lot. AP, we'll get into AP. We also have bimap. So bimap is kind of the same thing as these. We'll do bimap, except it's not going to change the state of the promise, or it's not, oh goodness gracious, the state, it's not going to change the type or the parameter of the async itself. What it's going to do is just, if it's in a rejected state, it'll run this function, the left function, and keep it rejected after running that function. Otherwise, it'll do identity. So why you would want to do things like this is, remember, map only works on the right hand side, or the right argument. So maybe I want to do constant silly jelly, right? Just so we know that there was an error or something that happened. So now if something is resolved, it'll do its normal thing, but now it will go ahead, and if we reject this with 23, it's just going to get us back our silly jelly, right? And if we had any other mappings here, like say we do that and then we want to add 10 or add 20, I guess. See, it won't do any of these things. It'll just give us back our silly jelly. Or, you know, you can even make it like initial thing is not cool, right? And it doesn't really matter, but and what this bimap is for is maybe you need to get things straight, like before you send it on to Redux. Like you can use this kind of like a func sort of thing. I think there's a middleware out there, things like that. But maybe you need to get it to report the error through your Redux flow. Well, if it's an error, you can just do your by map and then get it into the format that you want that Redux is going to expect, or whatever middleware you're using, or whatever you're using with it. Or maybe you just want to, at that point in time, set it up to be an action. Maybe you got the data back and now you need to put the type on the action to send it onto Redux and do all of its stuff. You can do all that with just this real simple by map and control that whole flow. So that's where by map and things like that come into. Now, here's the good stuff. I went through all that super quick. I'm sorry if I lost any of you or anything like that. But this is where the money is. It's this little guy right here. Well, these two guys, or people. I don't want to make it all masculine and chauvinistic and stuff. It's these things, app and chain. These are really, really awesome. And everything, all the cool stuff, just to let you know, we'll be seeing this a lot. This is the coolest signature ever, right? So we have this signature. And if you don't know how to read these, if you see an A or a B or something like that, typically, so what I could do is do monad M like this. So if I have like an A or a B, something that's not capitalized like a lowercase or isn't defined over here on the left side, that's saying this could be any type. Like this could be anything. This could be a string, this could be an integer, this could be whatever. We don't care what this thing is, right? And then this means it's a function. So this is a parameter to a function, or an argument to a function. And this is the return value to the right of the arrow. So what we're saying here is if you give me an A, give me anything A, I will give you back a monad of B. Okay? This is the best signature ever. Like there's so much power in just these simple, goodness gracious, 1, 2, 3, 4, 5, 6, 7, 8 characters, or 7 if you don't count, like if you were to count this as 1. There's a lot of power here in this, and a lot of that comes down to these two functions here. Like this is where we get the power from them, right? Chain and AP. All right, so now let's get rid of all this. No one likes working with simple little examples with set timeouts. Like that's boring stuff. No one wants to deal with that sort of stuff. So let's actually create an example. Okay, so we will, what are we going to do? We will use this from node function. Let's say let's at first read in a file, a JSON file, and then we'll output it into a new JSON file, right? So we'll do that here by going const. All right, so how are we going to read this in? That's, I guess, the first thing we should ask is how the heck are we going to read this thing in? So let's create a file called data.json. Okay, so this is our little JSON bit there. Our JSON file that we're going to read in. And let's go ahead and make this config is config.json. And we will, of course, do rainbows. And rainbows are always true. I think that's a law or something like that. So we'll have our little rainbows. We'll do the things like that. And now we have this simple JSON file, right? Pretty neat stuff. So we need to be able to read this file in. Well, Node has all kinds of stuff for reading files in. So what we'll do is we'll bring in read file, and we'll bring this in from, read file, and that comes in from require fs. So now we have this Node read file. A JSA, that's adorable. So if we jump here and we'll do read file. So this takes a file, some options, and a callback. So when we're dealing with this, we don't really care about this callback. That callback should be handled for us inside of it. The only thing we really care about are these first two parameters. And that's going to be the file name and the string that we want to bring in. So notice your encoding is default null. We don't want to bring this in as just a simple file. We want to bring it in as UTF-8. So we will do that. All right, so this is the neat thing. We can do read async, and using async, we have this function here called, we don't need that open anymore. We have this function here called from node. And I mean, it says from node, but it's basically follow any function that follows the CPS, or your last function is a callback function that returns an error or data, that whole flow. Yeah, so that's what these are for. So if you happen to have a function that matches this signature, where no matter how many parameters you have, your last one has an error and some data as arguments to a callback function, it will work with any file that matches that, right? So now we do from node, and we can do from node and bring in read file. So what this is going to do is give us back a function that's ready to be called, right? So let's just see what this looks like. We'll do a fork, and we'll do read async. And we want the file to be, what was it, data.json? All right, data.json. And we want it to be UTF-8. Is there a dash? I don't think there's a dash. Okay, so now that's it. It just took care of that. So now we have a function that will get us back in async. Anytime we call this function, it's going to get us back in async. That's going to load the file and put it on the resolved path. So if you notice, this matches our stuff. But there's an issue here. So this does not actually, this is a string. We don't really want a string. We're reading from JSON, so we need to parse this bad boy out, right? So let's create a cute little helper function here, and we're going to call this function const parse, and we will do, well, wait, before we do that function, let's just see what we can do with this async, right? So what we can do is we'll make our M again, and we will do read async, basically this whole thing. So we will df to here and do this and get rid of that. Okay, so this is going to get us back our async, basically. So if we look, we get the same thing back. All we did is just put it into this M. So the next thing we want to do is, if it's resolved, we want to take that and just do a JSON.parse on that, right? Parge, that's cute. We'll just do a JSON.parse. So now when this comes back, notice it comes back as an object now. It's not a string. If for some reason this didn't exist in a world where this file doesn't exist, you notice instead of getting back and running parse and throwing an error and things like that, we get back an error in our rejected. So now we know, hey, there was no folder, or there was no file, there was none of this. It just got rejected. So that's good stuff. So let's go ahead and write this. Now we're going to have another problem here, though. So this is all well and good because our JSON is well formed, but have any of you ever really used JSON .parse? Know that it loves to throw if it can't do things. So this isn't good news at all, because now we're throwing in our app, and async itself, it would break the functor laws if we were to catch errors and throw them, because they wouldn't behave the same way inside of I only use it with, I use it when I'm building out, like say I need to turn JSON into YAML, like say I'm building something for AWS and I got to get some configuration going and things like that. I'll use JSON.parse in that for building out like a YAML file that becomes either that or like Terraform stuff or things like that. So I use it mostly for silly things like that, and some web communication or some like custom web transport stuff, but that's the only time I use them. So Now, see, we get this error, and that's total bad news bears. Like, we don't want this to error, and we let it error inside of the async. You might think, well, hey, it errored in there like a promise. Don't we need to catch that and just reject it? And the answer is no, and that's because it breaks some of the functor laws. If we were to do something like that, it would break the functor law, because working it outside of the promise or outside of this async would throw. So I need everything inside of the JavaScript category to behave the same way inside of my async. So if it's going to throw outside of it, it needs to throw in while it's inside of it, and it needs to behave the exact same way. That's very important. Any function that you put in any of these containers need to map the same exact way. It needs to behave either the same way inside of the async as it does outside of the async. So since we have no special handling outside, I can't put special handling on the inside, or I break that law and you don't have a functor. And if you don't have a functor, then none of this works. You don't have the strict math in there. So there's a cool thing here. I have this function called try catch. All right, so what try catch does inside of Crocks, so what try catch does is it's going to, you give it a function and it's going to give you a function back that matches the interface of the function that you gave it. And from there, it's going to, anytime you call that function, it wraps the try catch for you. So if that function succeeds, it's going to return you a result. So I have this result here, which is another type. And it's a sum type exactly like our type, right? Which is good because we get some cool natural transformation goodness that comes from that. So this result type here is either OK or error. It's either in an error state or an OK state. So if now that I'm wrapping it explicitly inside of this function, then it's okay because this function will behave the same way inside as it does outside. And now we still have our beautiful functor with some error handling. So even though it's an extra step, it's really good for the mathematics of the whole thing. So now that we have this try catch, let's go ahead and make a fork function, or a safe parse. We're just going to call it parse. I mean, we know that it's safe or whatever. For this, we're just going to call it parse. And all we do is just put a try catch over JSON.parse. And JSON.parse doesn't need to be bound, so we don't need to do any this binding or anything like that to JSON, so we should be good there. And then here, P comes after F, so we'll just do this and throw parse in there. So now that we have parse, we can bring parse into here. Okay? That's from our silly little helpers. And this is just getting ridiculous is what this is doing. I don't think we need log in there anymore. All right, so here we're just going to bring parse in. And don't worry, we'll clean up. I'll get the, like this should probably, sorry. Sometimes I get so sloppy. It's like a teenage boy in his room. All right, so now instead of using this, we're just going to use this cool parse function instead of this JSON.parse. But now things get kind of weird, right? So I get an error back now. So I actually have what's going on here, because that returns a result, is M at that point when it runs is actually an async with a rejected. Well, okay. It's an async with a result in it. And then that result either has an error or it has a OK status. So this gets kind of gross, and that's only going to be, since we're doing it in map, that's only going to be for here. And then we have another error over here. So this type is just getting ridiculous. Error. Because then that OK at this point is going to be an object, and this is getting crazy like right now. And there's a lot that we need to keep track of. But this is where natural transformations come into play. So we have a natural transformation because these are sum types, and because a result is not a function type, it's a value type. I can go from a value type to a function sum type as long as the two sum types can match up. I get a natural transformation there. I can make it this this category or this object or this data type. I can turn it into an async, right? So instead of doing map here, what I can do is do chain. And remember, if you guys watched any of the Dr. Boolean things or anything like that, what chain's going to do is it's going to take something that returns another async, and it's going to take the value inside of it, get the async back, and combine them so I only have one async, right? So to do this, if we go down here, we have all these natural transformation functions all the way down at the bottom. So sorry. So these are our transformation signatures. And you'll see that we happen to have a result to async. So we're going to use the function signature since we have our parse function. See, we have a function that takes an A and gives us back a result of EB. So we can, we have this. We have that right there. And then it's going to take some A, and then from there that's going to be the JSON structure that comes in that's going to go to parse, and it's going to give us back an async of EB. So now remember that signature that we had, the A of M of B, right? That's what we have here. We now have a M of A of B, or an A to an M of B. With the async. Anyway, this signature is going to come up a lot. So what we need to do to bring that in is from Crocks. We can probably get rid of these two things. Is we need to do result to async. All right. And what that's going to do is turn the result of this into an async that can be chained with the other ones. So now, using this, we can get rid of that collapsing right there, right? So now, we go in, and you'll notice we don't have the result anymore. Remember, it was just the result of OK. Now, the whole thing came back. We were just getting the message back. Now, the whole thing comes back. It gives us our stack, gives us everything we want, and we have an error. But notice it didn't throw. Our program is still up and running. Everything's good to go, but we just captured that error handling. And by using this natural transformation, we were able to keep our data types the same. We didn't have to have an async of a result. I could just turn that result into an async, and they transform just fine. And by using chain, I can combine those. So if we have anything, like say we have a maybe or anything else that's a sum type, we can do this sort of thing and get all the benefits of the underlying type without having to deal with the complexity of traversing into the types themselves. All right, so now just to make sure this still works, let's go ahead and make this valid JSON here. Oh, there we go. And we get it back. Now we have our valid JSON. That's good times. Everybody loves some valid JSON, especially me. What time is it? All right, I only got about 15 minutes. So let's, oh man, this is a bummer. I wanted to get the reader in here. But that's okay. I'm going to take an hour break, or 15, 20 minutes, 30 minutes, something like that. I got to do some yard work and stuff. I live in Vancouver, Washington, and we've had beautiful days. So I need to get caught up on some yard work and things like that. But after that, oh no, I'll be back though. Don't worry. I'll be back. After that, I will be coming back on and doing some more, of course. So anyway, let's now get this to write. So now we have it to read. We have all this. It is kind of a real bummer that we're passing this stuff in. Hold on. All right. So now I want to take and say move this to a different file, right? So to do that, we're going to need to write this out. So we can build the same sort of thing. Write file though. So now we'll just take the write file that comes with Node, and we want to do a write async. For real, dog. Okay, and this is the same thing except okay, so now this is the same thing except it's a little different because this kicked off our flow. Like, we're not passing anything into this right now. We're just reading from this file. There's no data or anything going in. Whereas here, we need to actually write it to something, right? So what we're going to get back is this object. So we need to take this object and put it into the file. So here we'll take some x. We'll just make a quick, cute little function real quick. And we will do write file. Okay, and then we'll just call this output.json. No big whoop. And the second parameter to that needs to be the object that we're doing. So we're going to do json.stringify. And we're going to stringify x. Okay. Oh. Now we get all kinds of errors, which is great. I wonder what I did wrong. That's cool. That's cool as heck. Alright, what's going on here? So we do our write file, and then we do output.json. Huh. I don't know why it's doing that though. That's really weird to me. Huh. Oh. Types are hard. Still don't know why it's doing that though. Huh. That's really interesting. Well, it wrote it. It wrote it just fine, but I don't know why. Oh, I know why. Ah, I know why. This is ridiculous. Because it is output.json and I have... Alright, I need to fix this. Oh, that's hilarious is what that is. Stand by. Ridiculous. How embarrassing is this? Huh. Good. So now you'll notice it comes back undefined. Sorry about that. Add to, oops. Oops. All right. There we go. Okay. So what's going on, or what was going on with that is, and also I don't like this. Hold on. So one of the things you can do with JSON when you're doing your stuff is pass null and say how many spaces you want it indented. So now if I go in here and reload that, oops, Vim problems, huh? Now it's actually formatted and does all this stuff. So that's super good times. But now, I mean, that's working. Now the reason why we get back this there is because the actual write async or the thing like that, it returns a false, or it returns a how would you say? It returns an undefined. So what we need to do to get it to where we keep our data intact and things like that, let's close this out so we have some room here. So what we need to do is then map over this and do constant x. And we need to bring constant in. So we need to keep this data chain in check. It's kind of like what we do with a tap or something like that, where we need to control for a side effect or do something like that. We want to actually keep the data there. So we will, where's Crocks at? So we'll bring in, what are we going to bring in? What are we going to bring in? We're going to bring in constant. So we need to continue with x. So what we'll do is we'll return this, but then on that we're just going to map and return the x so we keep the data chain intact in case we wanted to do something else after writing the file. So now if you look, we still have the data intact. If we would have changed anything in there, right? So like say we do map and let's do, say we want to take rainbows out or config out. So we can do pick and we'll do config, or actually let's do omit. And we'll omit config. From that, we can bring omit in, right? So you notice now we only have rainbows. If we want, we can omit rainbows. And now we just get the config back. So we have complete control over that. What we could do after this, of course, is still write, like if we look at what was going on there, like we look at what our output.json is, notice we only have the config in there. It totally overwrote it. But what we can do is omit rainbows afterwards. So then what happens is it writes both of it, but the data we get back is that with rainbows there, right? So then we could do another thing where we could chain in another async and then write it without it. So like this is how simple, like this is how simple this stuff is. Like once you get the hang of it, we want to do a chain to go ahead and make different flows, right? So all I really need to do is this x, and because I'm copying and pasting, that should tell us, hey, there's probably a thing we can do to not do that, or to, how would you say, refactor. So now we'll take an x of that, and then we'll return this, and now we get the same sort of thing. Okay, except now it's going to output the new file to output A. So we've just wrote to two files like that simply, just by specifying things. So if we go up here, give this a refresh, we now have output A. So these files are written differently. We have our config, we have our rainbows. And again, a lot of this, we're just putting this together. I wouldn't write this normally like this, but just a way to go through it. But with these really simple types of things, where these simple algebras where I'm like, hey, just do this and then do this and then do this, I can do this like sequential processing and do other things like read to a file, read in a bunch of files, put them together and then write them. And it doesn't even need to be that. These could all be web requests, and you can mix web requests with data reads or like file system access. So say I want to bring in a bunch of stuff, I don't need to like use a request library or a fetch library for doing this sort of thing, and then use a different library for getting the promise to work with a file system. I can do all of my async work with just things like that. So I mean, yeah. So I mean, this is Crocks. This is what this does, and it's all of these functions, or it's all of these. We have all of these different data types, kind of like async. Like your IO, your list. We have maybes, pairs, state, unit, writers, like all kinds of crazy stuff. We have all the monoids that you can work with, and then all the functions to work with them. There's not a lot of good documentation at this point, but that's one of the next things. So I'm going to sign off here for about 30 minutes now. I just wanted to get an hour in, make sure my rig was set up, and then I'm going to continue on with this because now that we have this, one of the things you might notice is we have these files names here. Like this isn't very, how would you say, this isn't a very reusable flow. It's very one-off. So what we can do is capture the how would you say, kind of like when you're building a web page, you have all these environment variables, like this is the web service you read from, this is where you get your web socket, this is where you do this is where you do that. We have all this stuff based on environment there, but pretty much the code that we write could work on a staging environment, and it can work in a production environment, and we capture that environment in one place. So this is where a reader comes in. So for instance, this whole flow, if we think about it, is just a way to read a file, but we're very specific about which files to read in and which files to output. But what we can do is capture all of that stuff into an environment that just gets passed into this thing called a reader. And what a reader does is it provides the environment for you. Like I have a, where's reader? So what reader does is it's the same sort of thing. I'm putting functions in and doing things like that. But whenever I do a chain or I do one of these asks or whatever, what happens is it will give me the environment. So anytime I call it, hold on. So as I'm building this whole thing out, I can build out this whole flow that's going to build out our async. And then when I call run with, I pass an environment to it. So I might have, and you'll see when we get back online, input one or an input file. I could have an object, or on an object I could have the key called input file. And then all it does is it knows that's where the read comes from, and that's where it does this, that's where it does that. So that's what the reader will do for you, is it takes the environment and then lets you build up using that environment all these other different flows. So in about 30 minutes at 3:30, I'm signing off for now, but I'll be back on at 3:30. And yeah, that's all I got for now. Thank you guys so much for your time, and I can't wait to come back and show you how to get the reader to work with these silly async flows. And please, I noticed I haven't gotten too many questions or anything like that, but if you have any questions, I'm here for y'all. So if you guys got any questions, or you're like, whoa, what the heck's going on here? Please just hit me up. Or if I'm saying something wrong and you know better, like you know this stuff a lot better than I do, and I say something wrong, please interject in the chat or things like that, just so we can kind of keep the knowledge real. I totally would dig that. So. Anyway, I will see you guys in 1/2 of an hour, and gals, I will see you wonderful people in about a half an hour. Thank you so much for your time, and I look forward to talking with you guys again.